Now, let's start with the discrete random variables now. Okay, so I need to check the time. So I have 20 more minutes left. Let's start with the discrete random variables. Okay, my objective is to determine the expected value of a discrete function of a discrete random variable. So x is a discrete random variable and it has its own probability mass function px, which shows me the probabilities at certain values. Now, g of x is a real valued function, which is a transformation, any function, okay? But it's a real valued function. Bu ne demek arkadaşlar? Gerçek değerli bir fonksiyon. Yani bu fonksiyonun sonunda kompleks sayılar çıkmaz anlamına geliyor. Mesela karekök -1 gibi bir değer yok bu fonksiyonun içerisinde. Gerçek sayılar çıkıyor demek bu fonksiyonla. So g of x is a real valued function. And the expected value of g of x, is calculated how? By calculating the function of the all possible values that the random variable can take, and then we multiply it with the respective probabilities of these values and sum them up over the possible values. So it is just like the expectation, but this time, instead of multiplying the potential values of the random variable with the probability mass values, I calculate the function of these potential values one by one and multiply each of them with the respective probability mass value, then sum them up. Okay? So for all possible values that random variable can take with positive probabilities, I multiply the function of these values with the probability mass values, respective probability mass values, and sum them up. So this is as easy it can be. It is a very easy procedure. So let's do that. Let's calculate the expected value of functions of a random variable. So let's just say x is a random variable with probability mass function defined like this. So when, according to this probability mass function, this random variable, capital X, can only take one of these 5 values, -2, -1, 0, 1, and 2. And elsewhere, it can have 0 probability mass values. And we can calculate the probability mass values by plugging in these values into this function. So for example, the probability of x to take on x -2 value is -2 plus 3, which is 1 over 15. 1 over 15. So just like that, we can calculate the probabilities of all respective values according to this probability mass function. Now the question asks me, what is the expected value of the absolute value of x? The first question is this: what is the expected value of the absolute value of x? So what I am going to do is this. My function here inside the expectation is the absolute value function. So g of x is equal to the absolute value of x. So if I want to calculate the expected value of an absolute value of x, then I am going to multiply the absolute value of each respective value that the random variable can take with the respective probability mass value, which means absolute value of -2 will be multiplied with 1 over 15, absolute value of -1 will be multiplied with 2 over 15, 0, 1, and 2 are already absolute, right, because they are non-negative. So they are going to be multiplied with the respective probabilities, and then we sum them up. So 1.2 is equal to the expected value of the absolute value of x. Now coming to the second part, it asks, what is the expected value of e to the power x? Again, a function of a random variable, an exponential function of a random variable, right? So how do we compute the expected value of e to the power x? Again, for all possible values that this random variable can take, I am going to calculate e to the power x and multiply this with the respective probability mass value of x plus 3 over 15. So in this case, e to the power -2 over 15 for the first -2 value, I would get 2 times e to the power -1 over 15 for -1 value. For 0 value, I would get 3 over 15 times e to the power 0. And for the other values, again, I would calculate like that. And the expected value of e to the power x will be equal to 3.446. And finally, we have a third function, which is consisting on which contains a maximum function inside it. So the function is what? Maximum of x squared minus 3 and 0. So this means what? This function is going to be equal to x squared minus 2, x squared minus 3 if this value is greater than 0. However, if x squared minus 3 is negative, then it is going to be equal to 0. Okay? So the maximum of x squared minus 3 and 0, again, it's a mathematical function, and I am going to calculate the maximum of x squared minus 3 and 0 for all possible values that the random variable can take. For example, when x is equal to minus 2, minus 2 squared will be 4, 4 minus 3 will be 1, and maximum of 1 and 0 will be 1. So when x is minus 2, the function is going to be equal to 1. When x is equal to minus 1, check that out. X squared will be 1, 1 minus 3 will be minus 2, and when it is equal to minus 2, the maximum of minus 2 and 0 will be 0. So it is going to be 0 for this case. When x is equal to 0, again, 0 minus 3 will be minus 3, and the maximum of minus 3 and 0 will be 0. When x is equal to 1, again, we are going to get 0. But when x is equal to 2, the last value, again the maximum of 1 and 0 will be 1. Therefore, we are going to calculate the function values for all of them, and then we are going to multiply with the respective probability mass values and sum up. Therefore, the expected value of this function gx is going to be 0.4. And please notice that this g of x for random variable x, so for this random variable x, g of x can only take 1 and 0 values, which means g of x for this random variable is a Bernoulli random variable. Okay, it's a Bernoulli random variable. So that's a good thing that we learn. So you see, sometimes the functions of random variables can follow a spatially known random variable. Okay, sometimes they can be another random variable which we already know, just like in this case. Now, this is the last question, I guess, that I am going to solve for today. Then we are going to move to, we are going to leave everything to the next week. Now, check that out. This question is a very, very nice question, my friends. I have asked this question in a quiz in Boğaziçi University when I was a teaching assistant there. Okay, and this is a very nice question, but not a very large percentage of students could have solved it. Okay, if you have a conceptual knowledge, then you will realize that this is a very clever question. Okay, this is a very clever question. Only really clever students can solve. Okay, please read it with me. Stay focused. This is just going to be the last question that I'm going to solve. In a market research procedure, the test is performed over a group of at most 20 people, and test returns more reliable results if the group size is large. So there is a market research procedure, and in that procedure we apply a test, and this test is performed over groups of people, but that group size can be at most 20 people. Okay, at most 20 people. And if you want to get reliable results from the test, then the group size should be larger. For example, if you can find a 20-member group, if you find a group with 20 members, then you are going to get very, very good results from that test. However, if the size is smaller, for example, if you can only find 5 people, then the results in this test, they are not going to be very reliable. Okay, the larger the size of the group, the larger the reliability of the test results. Now, the researcher invites 20 guests to a session. Okay, so we invite 20 guests to a session, and independent of each other, each guest is likely to participate with probability 0.2. So I invite 20 different examinees, okay, so test subjects, and I know that not everybody is going to come. Okay, I invite them, but of course there will be a probability for each of them to participate in the exam. And that probability is equal to 0.2 for each invitation, for each examinee. And this probability or this arrival of the guests to this research, they are independent from each other, okay? So if I ask you this question, if I invite 20 people, if I invite 20 guests, each of which is likely to participate with 0.2 probability independent of each other, then the number of guests that will actually participate will be a binomial random variable, right? A binomial random variable with size parameter 20 and success probability equal to 0.2, if you remember the binomial random variable. But if you have formatted your brain after studying that chapter, you wouldn't remember, okay? Actually, you should not forget. You should not forget that random variable. So the researcher invites 20 people, each of which is likely to participate with 0.2 probability independent of each other. In that case, the total number of guests that arrive to this session will be a binomial random variable with size parameter 20 and success probability 0.2. After the test is performed, so the question is not ended yet, okay? But we have realized that this question is somehow related with a binomial random variable. After the test is performed, the researcher will reward the participants with a total amount of money. And if there are less than 3 people participate, in that case, every participant will be paid 1 Turkish lira. I mean, if you are inviting people to participate in your tests, okay, in your test, then you are going to pay them some money, right? So a reward money. So they are going to spare some precious time of their lives for your own research, okay? However, here's the thing. In order to encourage the people to come, the researcher says that if less than 3 people participate, for example, if 1 people participate or 2 people participate, then every participant will be just paid 1 Turkish lira. Okay? So if 1 people participate, I'm just going to pay 1 Turkish lira. If 2 people participate, I am just going to pay 2 Turkish liras in total to both participants. However, otherwise, which means if more than or equal to 3 people participate, then in order to encourage the participants, I will be paying X Turkish liras, where X is the number of participants in the session. For example, if out of 20 people, 10 of them come and 10 of them participate, then I am going to pay 10 Turkish liras to each of them, okay? If 15 of them arrive, then I am going to pay 15 Turkish liras to each of them. Now, if all of them arrive, then I am going to pay 20 Turkish liras to each of them, okay? If more than or equal to 3 people participate, then I am going to reward every participant with the X Turkish liras, where X is the number of participants in that session. So why do I do that? Just to encourage more people to come, okay? So everybody will think that I will come, and if the other guys will come, then I am going to get 20 Turkish liras. So everybody will think that, and because of this encouragement, all 20 people are going to come, okay? Hopefully. However, I mean, there is this probability distribution that we assume. I mean, though the money is encouraging people, we know that independent of each other, each guest is likely to participate with probability 0.2. So the question is this: what is the expected amount that I need to pay to the participants in any session? Okay, in any session. So you see, if different number of people arrives, then I'm going to pay a different total reward to these people, right? So the question is this: what is the expected amount that I need to pay in any session? Okay, the average amount. So I know that if 20 people arrives, I am going to pay 20 Turkish liras to each of them, which means I pay a total of 400 Turkish liras in that session. But for example, if 5 people arrive, in that case, I'm going to pay 5 Turkish liras to each of them. in that session, I'm going to pay 25 Turkish liras only. If, for example, only 2 people arrive, I'm just going to pay 2 Turkish liras, because in that case, I'm just going to pay 1 Turkish liras to everybody. So the question is this: what is the expected amount that I am going to pay? Okay, what is the average money that I am going to prepare when I invite 20 people? So what is the average amount that I'm going to pay? So that is an expected value of a function of a random variable, because the total reward that I'm going to pay in a session is a function of the number of participants. And the number of participants is a binomial random variable. So in this question, I know that in any session, the number of participants that will actually arrive to that session, that will also participate in that session, is a binomial random variable where the size parameter is 20 and the success probability is 0.2. Okay, so there are 20 examinees invited, each of which is independently and likely to arrive with 0.2 probability. Now, whenever X people participate, the total amount that the researcher needs to pay in a session is defined as this function. So if the number of participants is less than 3, then I am going to pay 1 Turkish liras to each of them, which means if X is less than 3, then I am just going to pay X Turkish liras. However, if X is greater than or equal to 3, then I am going to pay X Turkish liras to each of these X participants. Therefore, the amount of money that I'm going to pay is going to be X square. Okay? For example, if 5 people arrives, then I'm going to pay 5 Turkish liras to each of them. 5 times 5, it is going to become $25. But for 20, it is going to be 400. So X square is the reward that I'm going to pay if the number of participants are greater than or equal to 3. So the expected amount that the researcher needs to pay in any session is the expectation of g of x. Now, x is a binomial random variable. Depending on the realization of x, the reward is going to be also a random variable as well. So the question is asking me the expected amount of reward that I need to pay as a researcher, which is expected value of g of capital X. So this is the question here. Now, let's do that. For a binomial random variable with size parameter 20 and the success probability 0.2, the expected value of g of x, my friends, is what? The g of x function, gx function, multiplied with the respective probability mass values from 0 to 20. From 0 to 20, right? Because the binomial random variable can take one of the 21 values from 0 to 20. Sorry. Now, you know, my friends, my gx function takes the value of x for x less than 3. However, it becomes x squared for x values greater than or equal to 3. Therefore, I am going to write this expectation in 2 summations, where in the first summation, x is going to change from 0 to 2. In that case, I will say that it is going to be equal to x times px. And in the summation where x changes from 3 to 20, it is going to become x squared times px. Okay? So this is the expected value of g of x. Now I am going to do a magic trick. Okay? So let's just say I am going to make the summation not from 3 to 20, but from 0 to 20. Not from 3 to 20, but 0 to 20. Okay? But if I do that, I also need to subtract these x squared times px values in that summation, right? Because I am going to add x squared px values from 0 to 2 in that summation. Now I need to subtract these same values from 0 to 2 in that summation as well. So I am going to make this replacement. I will say that the first summation would be from 0 to 2 as x minus x squared times px, and the second summation will be from 0 to 20. Now, if you realize the second summation is equal to expected value of x squared, okay? And the first summation, for 0 value, it will be 0. For 1, it will be 0 as well. For only 2, it is going to be equal to 2 minus 4, minus 2 times the probability mass value at 2. So the first summation is very easy. So because in the first 2 component, it is just going to be 0. And the second summation is the expected value of x squared, if you realize. And the expected value of x squared is what? Remember the variance formulation, my friends. Remember the variance formulation. The variance of x is equal to what? Expected value of x squared minus the square of the expectation, right? So this is my convenient variance formula. And according to that variance formula, I can write what? I can write expected value of x squared is equal to variance of x plus expected square of the expectation if I simply take that negative part to that side. Okay? So I can find the expected value of x squared. And you know, for a binomial random variable x, the variance is equal to n times p times 1 minus p, which is 3.2. And for a binomial random variable, expected value is equal to n times p. However, we need to square it, which is 16. Therefore, variance x plus expected value of square of the expectation is 19 over 2. It is 19 over 2, but we also have minus 2p2 here. What is the probability mass value at 2 for a binomial random variable? It is n choose x times p to the power x times 1 minus p to the power n minus x. In this case, 0.1369. And when you subtract this value by multiplying it with minus 2, the result you are going to get is 18.9262. So that is the answer, my friends.